Hello everyone. This is my second lecture on Gauss elimination technique. And in this lecture, I will show you how you can say the system is inconsistent. Only you have to look for the pivot element, and if you see that after row reduction, your pivot is coming in the last column, then you will say that your system is inconsistent. That means it has no solution. So I will take one example, and with this example, I will show you how we can say the system is not solvable or the system is inconsistent. So let us see how we can say that. So let us consider the system. See, my question is, solve the system. Here I have the following equations: x1 minus x2 plus 2x3 equal to 4. Second equation, x1 plus x3 is equal to 6. Third equation, 2x1 minus 3x2 plus 5x3 equal to 4. And last equation, 3x1 plus 2x2 minus x3 equal to 1. I will write here x3. So you can see here I have 4 equations in 3 unknowns. My unknowns are x1, x2 and x3, and there are 4 equations. So first of all, I will row reduce it and see how the pivot is coming in the last column and how we can interpret whether the system is solvable or the system is not solvable. So first of all, I write my augmented matrix A augmented B. So I write all the coefficients: coefficient of x1 1, coefficient of x2 minus 1, coefficient of x3 2, right hand side 4. Similarly, I will jump into the second equation and I will write the coefficients of x1 1, no x2, so I write its coefficient as 0, coefficient of x3 1, right hand side 6. Similarly, third equation 2 minus 3 5 4, then 3 2 minus 1 1. Now I will look into the northwest entry and I will try to make it 1. See, it is already 1. I have highlighted it with yellow color. So I want to make all the elements in the first column below this 1 as 0. So I want to kill the element in 2-1 position, in 3-1 position and in 4-1 position. So first of all, I want to kill all these elements. I want to make at this position 1. So first of all, I will look at the entry in 2-1 position. It's 1. So I will multiply its negative minus 1 to first row and I will add it to second row. So see what I am getting. 1 minus 1, 2, 4. Next, minus 1 into 1 is minus 1 plus 1, that is 0. Minus 1 into minus 1 is 1. 1 plus 0 is 1, right? Then minus 1 into 2 is minus 2 plus 1 is minus 1. Then minus 4 plus 6 is 2. Similarly, I want to make the position where 2 is located, that is 3, 1 position as 0. So what is the entry here? 2. So what I will do, I will take its negative. See, the entry in 3, 1 position is 2. So I will take its negative, that is minus 2. So I will multiply minus 2 to first row and add it to third row. So see what I am getting, minus 2 plus 2, I am getting here 0, minus minus plus 2 minus 3, I am getting here minus 1, minus 2 into 2 is minus 4 plus 5, I am getting here 1, and 4 2 is 8, minus 8 plus 4, I am getting minus 4. Next, you can see I have in 4 1 position as 3. So what I will do, I will multiply its negative, that is minus 3 to first row, and I will add it to last row. So minus 3 plus 3, I have here 0, minus minus plus 3 plus 2, I have 5. Then minus 3 into 2 is minus 6 minus 1, I have minus 7. And finally, minus 12 plus 1, I have minus 11. So this is my first step. Now I will concentrate on the element in the next row and next column. So here it is already 1. If it is not 1, then I will divide the second row by that particular entry so that it will become 1. Suppose in place of 1, if I have 5, then I will divide the second row by 5 so that in that position 1 will come. Once it is 1, I will look at the entries below this one. It is minus 1 and 5. I want to make these two entries as 0. So first of all, what I will do, what is here? I have minus 1. So I will multiply 1 to second row and add it to third row. So what I am going to get, see, I am writing simultaneously 1 minus 1, 2, 4, 0, 1, minus 1, 2, and then I am simply adding the 2. So 0 plus 0 is 0. 1 minus 1, I have 0, minus 1 plus 1, 0, 2 minus 4, I have minus 2. Next, I want to make here 0. So what is the entry here? Entry here is 5. So I will multiply minus 5 to second row and add it to last row. So I will get here 0, minus 5 plus 5, I have 0, minus 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 plus. So 5 minus 7, I have minus 2, and here minus 5 into 2, so minus 10 minus 11 minus 21. Minus 21. So I am getting this thing. I simply interchange the last two rows. I simply interchange the last two rows. So I will get 1 minus 1, 2, 4, 0, 1, minus 1, 2, and 0, 0, minus 2 minus 21 and 0 0 0 minus 2. So first of all I divide the second last row by minus 2 so that I will get 1 there. So for that, and below this I have 0. So again I will divide the last row by minus 2. So I will divide second last row and last row by minus 2. And once I do that, see what I am going to get. I am going to get 1 minus 1, 2, 4, 0, 1, minus 1, 2, 0, 0, 1, 21 by 2, and 0, 0, 0, 1. So now let us look at the pivot. Let us look at the pivot. So see, in first row, this is my pivot. In second row, this is my pivot. In third row, this is my pivot. And in last row, this is my pivot. So you can see the last pivot. You can see the last pivot. The last pivot is in the last column. You can see, if I will see the last column, then you can see last column contains pivot. So this indicates no solution. The question is why? Because if I write the last equation, then this indicates an equation of this type where we have 0x plus 0y plus 0z, that is equal to 1. So now you can see here what are the values of x, y, z which when substituted in the left hand side of the equation can produce 1, that is non-zero entry. So you can see whatever values of x, y, z we will substitute in the left hand side of the equation, that upon multiplication by 0 will become 0. So no such xyz exists which when substituted in the left hand side of the equation will make it equal to 1. So this is the case of no solution. So when you see that your pivot is coming in the last column, you simply write the system is inconsistent. So here I say that the system is inconsistent. Okay. So pivot in the last column indicates there is a no solution or the system is inconsistent. In the next lecture, we will see how missing pivots will indicate that the system has infinite number of solutions. In fact, it has a free variable. So first case is that for solution to exist, pivot must not come in the last column. So if pivot is not in the last column, means it has a solution. So you discard the last column, and after that you look at the remaining columns. If there is a column with missing pivot, then it indicates the free solution. And if free solution exists, then definitely there is an infinite number of solutions. So that will be the target of my next lecture. Thank you. Thank you. See you in the next lecture.